Welcome to IME webinar. The topic for today is SolidWorks Simulations Advantage in High-Tech Industry. My name is Eng, the Applications Engineer in IME Technology. The agenda includes trends and challenges in high-tech industry, SolidWorks solution, simulations case study, global customer success story by implementing SolidWorks, and lastly, Q&A sections. First, we will look at the latest trends and challenges in the high-tech industry. The latest trend, evolving ECAD software to new level of complexity. Second, the demand for more functionality to the same size or smaller package. This industry is driven by the competitions to create smaller devices with increased functionality. Third, increased functionality drives more complex design in the smaller enclosure. Due to market demand, product enclosure cannot grow in size but need to maintain their size or get smaller even with the increased functionality of new model. Fourth, the emergence of new global environment standards like restrictions of hazardous substances (RoHS) in order to sell into foreign market. Finally, more traditional hardware components such as switches and display are being replaced with software functionality. Challenges in the high-tech industry consist of 5 main sections, which are time to market, design innovative product, smaller and lighter product, sustainable design, and design process management. We will go in detail for each section in the next slide. First, the challenge for high-tech industry is to accelerate time to market in order to earn the profit. High-tech industry develop various of conceptual design and looking for the optimal design. The testing in physical prototype during the development process can be reduced in order to get the product to market faster. Second, there are time to time renovate better product design. Electrical and mechanical design requirements must be seamlessly connected in the design process. Another challenge is to find a smaller, lighter, and better product. Packaging design in smaller space requires extreme precision for assembly modeling. Functional behavior of electronics must be carefully simulated to ensure product integrity. New material help ensure that product can be lightened without compromising strength and durability. Next, producers of high-tech items must take into account end-of-life considerations for their product. They are looking for solutions to validate design integrity while designing to find the effective and efficient material to achieve sustainable results. Finally, the challenge faced by the high-tech industry is design process management. Successful companies must share design and analysis information across the enterprise. The file collaboration is important to ensure design teams have immediate access to the latest product data. This is the typical role in the high-tech industry. For the head of engineering, they would like to reduce the need for physical prototyping and yet achieve the optimized result during design. Capabilities needed are able to simulate the product behavior under actual testing in digital environment, optimize the design and evaluate different design concepts in certain scenarios, like temperature distributions for each concept. For the IT director, they are facing the challenges in maintaining records internally and provide documentations to comply with government regulations. Capabilities needed are design process management tools to help the files check in or check out in one system platform, history recognition and data stamping, and able to produce information to generate format for suppliers and customers. Now, let's look on the SolidWorks solutions in solving the high-tech capability. For the challenge of design innovative product, the SolidWorks 3D CAD design can be implemented, which integrated rapid prototyping and electronic capability. For smaller, lighter product, assembly modeling in SolidWorks can be helped with simulations integration. For sustainable design, SolidWorks sustainability can be used to optimize the material selection. For the design management process challenges, the SolidWorks Enterprise PDM is implemented to manage huge data in server and able to communicate the file for each department securely. Lastly, for the time to market challenge, SolidWorks 3D software is helped to design and produce engineering drawing as well as simulations in one design platform to shorten the design cycle and accelerate the product to market faster in order to stay competitive. This is the overall SolidWorks solutions to deal with the high-tech industry challenge. In this webinar, we will focus on the SolidWorks simulation. What is design simulation? It is a phase inside the design process to test the product performance and behavior virtually for a wide range of real physical scenarios such as structural, motion, fluid dynamic, heat flow, environmental impact, and multi-physics. Design simulation is aimed at ensuring that a product fulfills the design user need and specific technical requirement. If you could provide product designers a tool to test their ideas and get meaningful technical insight while they are designing, they could run what-if scenario to ensure design optimization and reduce the need of costly real prototyping. These are the simulations toolbox that integrate with the SolidWorks 3D design software. Simulation capability include SolidWorks structural analysis by simulation, motion simulation, flow simulations, and plastic injections analysis. Without further delay, now we will take a look on some of the simulation case study specifically for the high-tech industry. For the first case study, we will simulate multiple design concepts. In most of the engineering design situations, there will be several design alternatives or options. SolidWorks provides design configurations using which variations of the designs can be created. SolidWorks simulation support design configurations and the design validations can be done for any of all the design configurations. Result of each of the design variations can be stored in the same model. This helps the decision-making process for the best design option and the effect of change in each of the design variations. Test the powerful capabilities of the SolidWorks flow simulation for testing thermal performance of your design. In this electronic enclosure, we are going to compare design to find the best option for minimizing the heat buildup. We will look at having fans inside the box on the case as well as the effect of different heat sink design. The model setup starts by defining the air inlet. If there are slot or hole pattern on the vent, you can easily account for this without the need for geometry complexity. Within the computation time, just specify a couple of parameters of the hole pattern and you are good to go. The fans can be specified from a large built-in commercial library or specified manually. Heat source for the electrical components are specified. SolidWorks flow simulation include the ability to model semiconductor heat transfer such as this CPU. Goals are then set up for key results or area of importance such as temperature of the CPU, integrated circuit, and memory chip. SolidWorks flow simulation excel in providing the ability to review the result and easily gain insight into the performance of the design. The section plot allows you to look at the cross-section of the model at any locations and select for a wide range of characteristics such as velocity, pressure, and temperature. A surface plot or heat sink provides a clear view of the temperature distribution on this component, making it easy to identify uneven cooling and potential hotspots. ISO surface are used to show results of the same magnitude in the design, such as the air temperature. You can readily adjust the value being shown on the fly as well. You can also display multiple value layers as well as adjust the color and transparency of the ISO surface plot. With the flow trajectory, you gain incredible insight by visualizing the actual fluid flow and can see far more than you would in any real experiment. With the ability to animate, result, and interact with the model, you gain great understanding on the product performance. Here, the swirl generated by the fans and the recirculation coming from under the PCB is easily detected. The Compare tool allows us to easily compare visually and numerically the different design concepts and select the best options to move forward. You can select from the current plot to surface or goal result and compare this over a subset of all of the design variations. SolidWorks Flow then loads each result set, captures the design information, and collapses it into image and table for quick and easy review. Switching to the external fans configurations, we can see that the recirculation has been eliminated and temperature have dropped. With the pin heatsink design, temperatures are not as low. Looking at the numerical result confirms this with temperature in the CPU significantly lower with the external fans and existing heatsink. With its intuitive and powerful flip flow and heat transfer capability, SolidWorks flow simulations enable product engineers to improve quality early in the design process. Second example, let us look what are the requirements you need to consider when you design components which generate heat, and this heat has to be dissipated properly. To do this, there are so many formulas, and it is difficult to do by the hand calculation. We will show you the demonstrations of this chip simulation and how it is integrated with the SolidWorks 3D CAD software. This is the computer chip. The engineering drawing has been created, and we can see that now the current design dimension is 3.17 mm from the chip end to substrate. The steady state study was created. First, the material for each chip can be defined under the material library. If you want to customize the material, you can save it under the Customize folder with its unique material property. From here, you can see that the thermal conductivity depends on the temperature. The simulation setup includes defining the thermal resistance between the chip and the substrate. Heat power for each chip with 0.2 watt and convection parameter for each component with environment. After the setup done, we can review the temperature distributions in this chip assembly due to the heat source, thermal resistance, and convections that we defined previously. If you want to calculate the stress due to the result you obtain from this steady state analysis, you can easily import the temperature result to the thermal stress analysis. From here, you can review and study the stress displacement due to the temperature calculated in the previous steady state analysis. You also can run specific study in this assembly as well, like the frequency analysis to find out the natural frequency that will lead to the resonance phenomenon. We have calculated 5 mode shape, and you can animate to see the behavior. Under the list resonance frequency, you can find each mode with its natural frequencies value. If you would like to minimize the natural frequency, you can change the chip location, but there are many variables can be controlled. With the optimization, you can easily input the parameter, requirements, as well as the design goal. Lastly, you can review the optimized result. From this optimization, if you calculate many iterations, and you can review each iterations as well. The model will update it automatically based on the design variable. So, as well as the drawing will update it to show the latest design. Another case study shown here is the motion simulator DVD player. A DVD player manufacturer develops a mechanism to open the tray to load the DVD. They do not know the correct size of the electric motor that they need for their tray mechanism. By performing a motions analysis, they are able to sizing a motor that consumes the least power and opens the tray in a predefined time. This is the DVD player assembly. All the components are connected to each other by the mate. In order to calculate the motor torque required to open the DVD tray, motion simulations can be performed. From here, you can add a rotary motor on the gear pinion. This is the kinematic system, where there is a one driving motion. Other components will be moved based on the mechanical connections as we have defined under the mate. You can play the animations to see clearly how the mechanism. Lastly, we can plot out the motor torque required for this mechanism, and you can sizing the motor based on the result you obtain under the motion simulation. From here we can see that the motor torque required is 0.011 Newton mm for this DVD player mechanism. There are a lot of worldwide customer success stories by implementing the SolidWorks solution. For example, Thermo Electron Corporation, an infrared spectrometers manufacturer which is used by a wide variety of chemical analysis processes and procedures. They are ensuring the casting had no resonance in the frequency range that would be transmitted adversely to the optical detector. By using SolidWorks simulations, the learning curve is reduced and the result were within 5% of the empirical value. Another example shown here is Sorrento Network, a leading supplier of optical networking equipment for carriers and enterprise worldwide. The challenges facing are both designers and engineers must understand thermal issues and constraints in the design phase of a project. By implementing SolidWorks simulation, the results are easy to interpret and able to review certain design criteria. Next example here is Delphie Packet Electric System, one of the world's leading manufacturers of automotive electronic components. They need a tool to quickly design and test the connection system inside an automotive electronic module. After using the SolidWorks simulations, they are able to move from the concept to the first structural analysis in just 2 days. Time saving directly related to the money saved. As a summary, the high-tech industry has its unique business challenge like time to market, design innovative product, smaller, lighter product, sustainable design, and design process management. SolidWorks has proven the solution for these critical business challenges, and thousands of SolidWorks customers are successfully addressing these business issues today. Last but not least, if you have any questions related to today's topic, you are most welcome to send them to me. You can reach me through my email wsng@alliancecadcam.com.my or contact our IME SolidWorks Technical Hotline at 1300 882797. Hope to see you again. Thank you.